Hello, folks. We are once again back after a long time after we have finished our first textbook. Now we are going to the second textbook. Here, the first chapter, that is the chapter number 7, which we are going to begin with. That chapter is called as integration. And integration is basically anti-derivatives, just the opposite of what we do in derivatives that we'll be doing in integration. So actually, as we did in derivatives, here we need to have the list of formulae on the basis of which we will be calculating the derivative of the integration of whatever functions that they give us. So as we did in the derivatives, we will prepare the entire list, and then on the basis of that we will be doing the derivative, the integration. But to begin with, the very first exercise 7.1 in the textbook, they ask us to look at integration as antiderivatives and try to get familiarized with that idea. Later we can have the list of derivatives, and from there we can proceed and find out the integrals of the given function. So that's what we're going to do. So right now we are just going to find the antiderivatives, and not exactly integration but antiderivatives, and then proceed and find out the remaining. So the first exercise, as I always keep telling you, that we are doing this with reference to the old textbook, not the new one where we have a lot of deleted portions. So the deleted portions is okay for the 12th standard, but if we're preparing for IIT, and other competitive exams, then that will not be sufficient. So that is why all the questions that are being done here is with reference to the older textbook, the one that has got undeleted portions. So that's about it. We are with the exercise 7.1, which says that find an antiderivative of the following functions with the by the method of inspection. So you have to find out the antiderivative. In fact, they ask us to find the integral, but then to begin with, we'll find the antiderivative. So the idea is d by dx of which function can give you sine 2x? That's the question. If you have to get sine 2x, what function could it be? So basically it could be cos 2x. We know that cos 2x, had we taken cos 2x, then we would have got the antiderivative as minus 2 times sine 2x. That would be that could be our derivative, not the antiderivative. We would have got the derivative as minus 2 sine 2x. Now since you want the integral of this or the antiderivative of this, so we kind of apply antiderivative on both sides. So when we apply antiderivative of this derivative, so this becomes an identity function because they are opposites of each other, and here we are applying the antiderivative of minus 2 sine 2x. So to get the antiderivative, the negative 2 and all that can go out. Now this being an identity function cos 2x, this remains as cos 2x, and the negative 1 over 2 can come here. So you get antiderivative of sine 2x as minus 1 over 2 cos 2x. So that's how it is. Okay. So the antiderivative of sine 2x is minus cos 2x over 2. How we got it? This is the procedure. So also we can take the second problem here. They give us a second problem which says that you find out the antiderivative of cos 3x. So let's look at it the way we looked at it previously. If we had to get the derivative of cos 3x, then we would be looking at the function sine 3x. Sine 3x would have given you the derivative 3 cos 3x. So if we were to apply antiderivatives on both sides, then you would get the antiderivative of 3 cos 3x. So 3 is always, it can move out. So the antiderivative of cos 3x, the antiderivative of cos 3x would have been, this of course will become identity. It would be 1 over 3 times sine 3x, because we moved the 3 on the other side. It's only that much. We look at it in a different way so that we get used to the idea of antiderivative. If that's all, we can move to the third problem, which says that you have to find the antiderivative of e raised to 2x. If we were to look at e raised to 2x, if we had to get the derivative, then actually e raised to 2x as a derivative would have given you 2 times e raised to 2x. We want the antiderivative of, let's apply antiderivative on both sides. So it's like 2 e raised to 2x. 2 can coolly come out and then go on the other side. So you're getting the antiderivative of e raised to 2x as 1 over 2. This will become identity. So 1 over 2 e raised to 2x, because that's moving on the other side. It's only that much. So this is the antiderivative of the third one. Let's move to the fourth question. Check what it is. It says that it is ax plus b the whole squared. So you have to get a function which is going to give you the derivative ax plus b the whole squared. So we know that if you have to get ax plus b the whole squared, we always have the derivative nx raised to n minus 1. So keep that in mind. So therefore it could have been ax plus b whole raised to 3 actually. So if that was the case, then you would have got the derivative 3 times ax plus b the whole squared times a. So when we apply the antiderivative, so antiderivative of all this, we'll make this identity on this side, and here the antiderivative of 3ax plus b the whole squared a. Since you want only this 3 and a, you can take on the other side. Here already identity is there. So antiderivative of ax plus b the whole squared will work out to, because 1 and 3a can come on the other side, ax plus b the whole cube. Why? Because we are taking these both. Since we require only this we are taking on the other side. That moves out, and these are identity. So that's all. So you're getting the antiderivative as 1 over 3a times ax plus b the whole cube. Let's go with the fifth one. It says that sine 2x minus 4 e raised to 3x. It is sine 2x minus 4 e raised to 3x. So let's look at it as two functions and get the antiderivative separately and then bring them together. So let's call u as sine 2x. Then du over dx would have been 2 cos 2x. No, we will not call it like that, because that way we are not going to get what we want. We are going to look at which function is going to, here we are going to check which function is going to give you sine 2x. So that's very clearly cos 2x. Cos 2x will give you the derivative minus 2 sine 2x. And since you want the antiderivative of sine 2x, so antiderivative application on both sides, you will get antiderivative of minus 2 sine 2x. So the antiderivative of sine 2x is going to be minus 1 over 2 cos 2x. That's one part. Now look for this part also. If you go for the other part, if you are looking at the derivative of e raised to 3x, then e raised to 3x has the derivative 3 e raised to 3x. Since you only want e raised to 3x, we'll apply antiderivatives on both sides, and that way you'll have the antiderivative of e raised to 3x. The 1 over 3 can go on the other side. So it will become 1 over 3 e raised to 3x. When we write it, of course, that 4 will be there. So therefore, the overall antiderivative, let's write. For the first part, we have got minus cos 2x over 2. And for the next part, because the 4 is there, so it will become minus 4 over 3 e raised to 3x. That's all. So this is how we are looking at the given function as an antiderivative. Instead of finding the integral, first we are trying to make ourselves understand that it is also antiderivative. Now, in the upcoming sessions, we will be taking up all the formulae that will be helping us to solve the problems further. So the upcoming questions in the exercise we'll be directly solving with the help of formulae. So we'll require a full list. So we'll prepare an entire list, get ourselves equipped with that, and then go on to solve the remaining problems. That's all for this video. With more problems, we can meet in the next video. Meanwhile, you have to be putting in efforts to popularize the channel and spread the word amongst your known people. Thank you.